Welcome back. Let's practice. All right. So the rectangular coordinates given here is -2 to 0. Let's try to sketch this. -2 means you go backwards in the x coordinate. Let's use a different color here. All right. So it's right here, and then you go 2 units to the in the y direction. So maybe around here. All right. So this point is -2 to 0, right? Right here, okay? It's on the xy plane. I hope this is clear from that. And so this is -2, 0. So you don't really, I mean, hopefully you don't have to use those, formulas like these complicated formulas. Formulas are nice, and sometimes you have no option but to use these. But for these conversion problems, I really want you to sketch and figure this out. All right, now remember the cylindrical coordinate system. And by the way, I guess I should also write x, y, z is what you need here. These are what are the coordinates called? R, theta, z, the z being the same. And then spherical or Greek, rho, theta, and phi. Okay, so these are the coordinates we need to find. R, you remember what R is? It's how far this point is from the origin. Well, that's easy. This has to be 2 square root of 2 because you have 2 here and 2 here, that the hypotenuse has to be 2 times the square root of 2, right? And then theta, right, remember this is x, this is y. You're trying to find this angle. It may be helpful in this situation to look at this picture from the top. Where is this point? It's right here, right? That's -2, 2. So you're looking for this angle, and from the picture, it's clear. It has to be 90 degrees plus 45 degrees, 135 degrees. If you are a child and not mature enough, you use degrees. And once you are a mature adult, you are expected to use the radians, because that way people will take you seriously. And so what is that? Well, it's 3 pi over 4, okay? And so that is your answer here. And then finally z. Well, z is the same as this thing here, so that's 0. Okay, see how easy that was. Okay, and you want to do the spherical? Yeah, let's do spherical. Rho is how far this point is from the origin. Well, it turns out to be the same as r in this case, because there is, z is equal to 0. So how far is this point from the origin? It turns out to be 2 square root of 2. Theta is the same theta, so that's easy also, right? Now, what is the angle phi? Remember, angle phi measures the this vector from the positive z-axis. How far, or what is the angle between the positive z-axis and that vector from 0 to this point? And the answer is, of course, you have to go 90 degrees down from the positive z-axis. And so this is pi over 2. That is your phi. Now, if you look at this, it doesn't look anything like this point. And that's because you are so used to rectangular and perhaps cylindrical coordinates or polar coordinates. And so you haven't been an experienced user of the spherical coordinate system. I hope you will be soon. And then you can see, oh yeah, this means that the point is on the XY plane. All right, another one. 3, 0, 3. All right, so in this case, you go 3 units in the x coordinates, x direction. Y is equal to 0, so we don't go in this direction. But then z is 3, so it will be there. And so your vector is like this, and here's your point. Okay. Now notice here, this is a point on the xz plane. Y is equal to 0, right? And so based on that, I think you can find what your R is. And by the way, if you look at this projection from the top, it's basically right here, okay? 3, 0. This is a point 3, 0, 0. That is a projection of this point on the XY plane. So what is the R? That's how far this point is from here, right? The yellow little segment here. And the answer is, of course, this is 3. Okay. Now, your R is going to be square root of, 3 squared plus 0 squared, and you can get 3 that way too. But it's a lot easier if you can picture and sketch this. You can figure this out. What is theta? That's the angle that the yellow line makes with the positive x-axis, but it is on top of the positive x-axis, so it has to be 0. And you see that? The theta has to be 0, right? Because we haven't moved from the positive x-axis. And how about z? Z is the same as this, and we're talking about up here, so this is 3. 303. Wow, this has the same name in the cylindrical language as in the rectangular language. So it's one of those rare points where whether you speak rectangular or cylindrical, your name stays the same. All right, and then how about the spherical? How far is this point from the origin? This is 3 here, this is 3 here. And so the distance from 0, 0, 0 to 3, 0, 3 has to be 3 square root of 2, right? It's the hypotenuse of that 45, 45, 90 degree angle, a triangle. Theta is of course still 0 because that's the same theta as this. And how about phi? You're trying to measure how far, you're trying to measure the angle that this vector makes with the positive x-axis, positive z-axis. That's exactly 45 degrees because, because you have 3 and 3, right? And so that would be 45 degrees, otherwise known as pi over 4. Okay, get that? You can always use the formulas to come up with these answers, but it's much better to come up in this way. This time, next 2 questions, I'm giving you the cylindrical coordinates, right? And now we convert to rectangular and spherical coordinate systems. It's usually easier for you to understand these in terms of rectangular coordinate systems, and then you can, rectangular coordinate system, and then go to the other one, which is the spherical system. Okay, so cylindrical system gives you 5 pi, 2, okay? So the fact that it's pi means you have to go from, from 0 to pi. That's all the way from the positive x-axis to the negative x-axis. And this one is telling you to go 5 units from the origin, 1, 2, 3, 4, 5. So this will put you in this point that's -5, 0, 0, until you see this 2, which is 2 units up higher, right? And so your vector looks like this, and that's the vector from the point 0, 0, 0 to the point described by this. Okay, we got it. This is the point. Well, now we know what the answer is, okay? I mean, for the rectangular coordinate system, what is the x coordinate? Well, I just said it's -5, right? So where did this negative come from? Well, the fact that pi puts you all the way to the back side, the negative x side, and then you have to go 5 units. So that's why this is the case. Again, the formula will give you x is what? R cosine of theta, and 5 times the cosine of pi is -5. So you can get that answer, but this picture makes it much easier for us to visualize the point. How about y? Well, y has to be 0. Again, clear from the picture because you haven't moved in the y direction. Z is 2 because z is 2, okay? All right, so how about here? How far is this now? Remember this from the side, this is what it looks like. It's 5 here and it's 2 here. How far is rho? How long is rho? It's a square root of 5 squared plus 2 squared. That's 29. You get that? Okay, and how about theta? Theta is theta, even in the spherical coordinates. So you basically copy this answer here, pi. That is this answer, how far it is from the positive x-axis. Now here's the tricky part, okay? Somehow I have to figure out what this angle phi is. This is the angle phi, which is the same as this angle phi, okay? And there is really no nice way of expressing this except with the inverse function. And so if you use 5 and 2, you can call this the inverse tangent of 5 over 2. And that's probably the best way to write that, okay? Of course, that that makes sense from the geometry or the trigonometry of this picture. All right, let's go into the next couple. And next one, square root of 2, pi over 2. You notice here for these cases, if the cylindrical coordinates are given, this is usually the first thing I look at, pi over 2. That will take you from here to the positive y-axis. And then you go in this direction, square root of 2 units. okay, whatever that is. And that's 1.4 something, right? 1.414, blah, 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 is the square root of 2. And then you go 1 unit up here, okay? So the point we're talking about is the tip of this vector here. And you see that? Okay. And so that gives you, the triangle looks like this, square root of 2 and 1. First of all, what is the x? Well, x is pretty easy, right? Because we are right on top of the positive y-axis, so x has to be 0. And how about the y? Y has to be square root of 2. That's from the picture. And then you move up by 1 unit, so z is 1, okay? And z is 1 here. Z is 1 here because z is 1 here. And then for the spherical coordinate system, now how far is that? How far is the origin from the point? That would be the hypotenuse of the triangle, a right triangle, whose legs are 1 and square root of 2. So again, Pythagorean theorem, this will say this square plus this square is the square of rho, and that's 2 plus 1, and that would be 3. And you take the radical, the square root of 3 is the value of rho, right? How about theta? Theta is pi over 2 because theta is pi over 2. Okay, and finally, what is this angle here? That's this angle also, right? And again, you have to say something like it's the inverse tangent of square root of 2 over 1, which is the square root of 2. Okay, so there's no nice way of writing this except using the inverse tangent sign function. All right, now the spherical coordinates are given. This is, the least familiar one for us typically. And so this 3 gives you the fact that the point we are considering is 3 units away from the origin. Well, that's like anywhere in, in the sphere of radius 3, like whatever. Okay, so that really is hard to tell. Let's not worry about that, okay? Eventually, we'll use that. But then, what else do you know? Well, theta is negative pi over 2, so that will make you go this way. And then phi is pi over 2. That is an important point. So you go this way, right? From the positive z-axis, pi over 2. This will put you on the xy plane. So you'll end up with this point, okay? And it's the point 3 units away from the origin. So here's 3. And remember, these 2 angles sort of give you the direction to go to from the origin. And so this is my point. What are the coordinates? X is 0, y is negative 3, z is 0. Did you get that? Yeah, because this is the point on the negative y-axis. That's the point that's negative z. Sorry, negative y direction. So it's a point in the negative y-axis 3 units away from the origin. So that has to be 0, negative 3, 0. In cylindrical coordinate system, what do you get? Well, the cylindrical, which is based on the polar. This, how far this is actually 3, that's r. And then what is theta? Well, the theta is negative pi over 2, that's this one here. And then you have to know what z is. Well, z is 0, okay? So those are the coordinates. Finally, you have a point described in spherical coordinate system as 2, 0, 0. 2 gives you the fact that it's 2 away from the origin. That could be in any direction. We don't know which direction you go to. But this is 0, which means you stick to the positive x-axis. And phi is 0, so that means it's on the positive z-axis. That must be this point then, okay? This is the point on the positive z-axis where the rho is 2. This is the only point, okay? So how do you write that point? 2 units directly above the origin, that's 0, 0, 2, otherwise known as 002, right? And then how about the cylindrical coordinate system? Again, if you project it down, this point down to the xy plane, it's this point, the origin. So r is 0. R can be also obtained by the square root of 0 plus the square root of 0, which is mysteriously 0. And then what's phi, or what's theta? Well, the theta is happen to be the same as this. In this case, it's irrelevant, right? Because if theta is pi over 2, it's still going to give you this same point. I mean, because rho is 0. And then finally, z is 2, right? So again, in these two coordinate systems, the point is called the same. But in spherical, in language of the spherical coordinate system, it is different. It's like, you know, your last name has now become the first name. That sounds familiar to us Asians. Okay, so that's how you do these problems. If you want to know more about these, you have a few things. In fact, all you have to do is to look up, you know, Google spherical coordinates or cylindrical coordinates, and you'll see a lot of information here. There's a small video, a short video of 8 minutes. If you click on this thing here, if you want to do a more detailed one, Professor Leonard, by the way, is a pretty well-known, YouTuber, and he has very long lectures, like an hour and a half lectures on calculus sequence. And so you can watch him. Just look up Professor Leonard, mathematics, and he basically records his face-to-face classroom lectures. And so like this is a 100-minute lesson, but the first 45 minutes involve the three coordinate systems. Okay, so before I end, I just want to answer three questions. Sometimes, many times, we use these coordinates to describe portions or subset of a space, right? So for instance, what is phi is equal to pi over 3? Okay, can you picture this? Maybe you want to pause this, and then when you think you know the answers to all these three questions, you can come back and do that. All right, so think of all the points where phi is pi over 3. Remember, phi is the angle measured from the positive z-axis here. So you go in all directions, go pi over 3, which is 60 degrees. What do you get? You get something that opens up 60 degrees from the positive z-axis in all directions. So then you can see this was going to be a cone, right? Where this is 60 degrees or pi over 3, okay, in all directions. So imagine like a flower opening up, you know, in all directions from here, and you will see a cone. So this equation describes a cone that opens up in centered at the z-axis or about the z-axis. Theta is equal to pi over 3. Now, this is phi is equal to pi over 3. This is theta is equal to pi over 3. The only difference is that Greek letter, okay, but makes all the difference. Because if theta is pi over 3, you know, here's 0, and then you go pi over 3 in this direction, that's 60 degrees. And the R and Z are not mentioned, so it's basically here. Let's go ahead and draw this in different picture here. It's basically all of these points on this vertical wall, which is constructed at the 60-degree angle with respect to the positive x-axis. And in fact, it goes beyond and to the opposite side as well. Okay, so the set of all points in R3 where theta is equal to pi over 3 happens to be a vertical plane, not a cone. And finally, what happens if rho is less than or equal to 2 and phi is less than or equal to pi over 2? Remember, phi measures the angle from the z-axis, positive z-axis. Pi over 2 will give you 90 degrees in all directions. So it'll go from here to, in all directions, to the xy plane, and rho has to be less than or equal to 2. So what kind of a thing is this? It's, as you can imagine, this is the semisphere of radius 2, okay? And so it'll be pretty much like this, radius 2. Okay? And so that is the answer to this question here, right? So what do I say? It's actually not, it's more than that. It's a semisphere, semisphere is not an English word. Okay? It's a hemisphere. It's basically what we call the Northern Hemisphere. Now, I don't want to call this the Northern Hemisphere because, you know, there's no north or south. when you talk about mathematics. Those are geographical terms. Hemisphere. Hemisphere. So it's a top sphere, but it's not. See, when you talk about the hemisphere, we're only talking about the points on the surface, okay? And its interior. All that is included in here. And because you have this equality here, all the points on the sphere and on the XY planes, XY plane within the radius 2 is covered, right? So this will be like a solid half ball. Okay, so it's like a solid ball. Think of a bowling ball, solid ball, and then just cut in half. The top half of this solid ball is what this thing looks like. All right, so I hope this has been helpful, and you are going to use these when we go into integrals in chapter 5. And until then, just remember that these things do exist, and these will help you eventually later. All right, so I hope you'll have a great rest of the day, and I'll see you next time.